Welcome everybody to Getting APIs to Work. Today we say hello to Simon Plenderleith. Hey Simon, how are you doing?
Hey Eric, thanks for having me. How are you doing?
I'm doing well, thanks. Thanks so much for joining, Simon. Simon is an independent Node.js consultant, and you're specializing in Node.js, and you're specializing also in JSON Schema as part of that work. And a little while ago, we had Ben Hutton talking about what JSON Schema is even used for APIs. And today we want to dive a little bit deeper, not just what it's used for, but also what it looks like, and really look at a little bit of code. And you agreed to do that with us. Thanks so much. Just to give us a little introduction, like what are you using JSON Schema for mostly in your work with Node.js?
Sure. So I'm mostly using JSON Schema for validating API payloads. So data that's coming in through a request to my APIs, I'm using JSON Schema as the first sort of stage of validation to sort of check all that data that's coming in. I have in the past, though, used it for things such as validating configuration that's being passed to command line tools, as it's just a really effective way of describing any kind of data. But these days, mostly APIs.
Mm-hmm. And the one question that I asked Ben, and I'll ask you the same question here because I find it interesting. So if you looked at JSON Schema, you can use it in different levels of, let's say, refinement, right? You can have very refined and complex schemas, or you can have very simple schemas that just check less things. Where in the spectrum do you see most of your work happening?
So it really varies. I think you can kind of go as simple as saying this data that comes in must be a string. And you could leave it there. Realistically, you're probably going to want to go a little bit further. But once you start building it up, it really is kind of a stage, kind of a case of you could start with something very simple and start adding in more rules, such as a minimum length and a maximum length, and then validating other fields. So it's not like you have to jump in with something really complex to start with. But as you move along and you start using sort of more of the rich features of JSON Schema, you might end up, say, having one schema that references another schema. Say you've got a particular format for addresses and you want to use that for a delivery address and for a shipping address. You don't want to be duplicating those validation rules, and you've got that kind of flexibility, but you don't have to start there. I think that's the nice part. One thing that JSON Schema intentionally doesn't cover, because it's only describing the data, it doesn't know anything obviously about your application or the kind of the data behind it, is if you have something kind of very application specific, for example, checking a username. So somebody's registering, you want to make sure that there's no duplication. You wouldn't really want to be handling that with JSON Schema. It doesn't offer any features for that. So after you've done validation of the data initially of the API payload with JSON Schema, you would then want to look at having some kind of further level of validation to actually check those kind of application, like logic specific things.
And I would assume in many scenarios that is like the way it goes anyway, that you have kind of a validation pipeline where at first, right, you check some things where, okay, let's see if is the username within the allowed length limits or whatever, right? And then you have a next step that does maybe these additional checks like the ones that you were mentioning. Now, as somebody programming with JSON Schema in Node.js, you must be using some implementation of JSON Schema. And one of the things I'm wondering about, which implementation are you using? And do you have a choice in JSON in Node.js, or is that kind of the only one that is available?
So the one that's kind of won out, there are a number of validators available for Node.js, but the one that's most popular is AJV, which stands for another JSON Schema validator. And it's really well maintained, has great documentation, millions of downloads every week. It's pretty much become the de facto in the JavaScript ecosystem, as it can also be used client side, as well as with Node.js. So yeah, that's kind of the go-to these days.
And as I think that's also something that Ben mentioned, probably in any implementation environment nowadays, you will probably find at least one implementation of JSON Schema, I would guess. Or are you aware of any environment where you would say, oh, I can't use JSON Schema, there's no implementation?
I'm sure there must be, but I certainly haven't encountered it. And if you on the JSON Schema website, that you'll see all the kind of usual suspects when it comes to languages, and there's at least a couple for every language. So I think it's pretty well covered in terms of various language ecosystems.
Yeah, that's my impression as well, and I think we'll see that this ecosystem probably will keep growing. Okay, now the next step for us, and you were kind enough to not just talk to us about JSON Schema, but also to prepare some examples so that we can really look at JSON Schema and talk a little bit through what it does look like, how does it actually work. This is not intended to be a tutorial, but I think it is useful to think of it as something where you can at least get an idea of how it works and maybe start considering using that in your own API design and development work. So let's look at that example that we are starting with. So Simon, what are we looking at here?
In this example scenario we've got here, it's a schema for validating a recipe. So let's imagine we've got an API accepts recipes which have a name and ingredients and so on, how long it's going to take to make the recipe or estimated time. And we want to validate the payloads that's coming through to our API with the recipe. We want to make sure that before we do anything with that data, that we're safe to actually use it, that it's what we expect before we kind of do any kind of processing or put it anywhere near our database. So that's what this schema is here. It's kind of just a way of describing the data that we expect to be coming in.
And it is structured in a way that it's relatively, it's almost kind of, you can just look at it and kind of make out a little bit what it's doing, I guess, just by reading through it more or less. So it seems to be something that is relatively readable, let's say like this.
Yeah, I think that's one of the real strengths for me of JSON Schema is that in large part, you might not know the specifics of the exact syntax that's required off the top of your head without looking at the documentation and kind of and learning them. But actually, for the most part, it's self-documenting and it's using fairly intuitive vocabulary. For example, over here we see like min length and max length, which I think you can reasonably infer is the minimum length and the maximum length for a thing, and then what things we have that are required as well. So yeah, it's quite nice as a form of documentation, for kind of creating that contract between consumers and APIs.
Yeah, it looks like something that you could discuss that, or at least show it to somebody who might not be an expert in it, and at least they kind of get a feeling for what they're looking at. And do we have anything else interesting in here, or things you want to point out that show us what JSON Schema is doing, how it's working, some of the basic mechanics?
Yeah, for sure. So we can kind of take a quick run through this schema here, and I'll highlight a few things, and then I've got an API over here which is written in Node.js, as we've already kind of mentioned. This doesn't have to be in Node.js. JSON Schema works with pretty much any language you can imagine. Here I'm using a framework called Fastify, and it's really nice because this Node.js framework actually integrates the AJV validator, and so the default mechanism for validation is JSON Schema. So it makes it really simple to drop in. And so here we're defining this route. So we're saying we've got a post route, and then we've got the path for it. And then over here, we're saying we want the body for our request to be validated against this recipe schema. So that's the schema we were looking at just over here. So any request body that comes through to this particular endpoint will get validated against that schema. If the data validates, then it will run this route handler function, which isn't really doing anything in this case, as it mentions in this comment. In a real application, we'd actually be putting some data in a database. So that's the kind of the premise of what we've got here. But before I show you that running and kind of how that behaves when we make requests to it, I'll just kind of quickly run through this schema a little bit here. So every JSON schema should have a $schema property. And that's important to tell the validator. In this case, we're using AJV in this application, whatever validator you might be using in your language. It needs to know what version of JSON schema you're using. So there are different versions. They're now kind of versioned by year. But Draft 07 is the most widely supported. There's lots of different tooling around for JSON schema, and Draft 07 kind of covers all the fundamentals. There are some additions that have been made since in further drafts, but it's worth kind of mentioning there are different versions. And as long as you kind of start with Draft 07 or higher, you should be good.
Okay, so this one then allows the validator to start looking through it and make sure that they're using the right understanding, I guess, of the language. So now we continue with a type.
Absolutely. So each, like you say, the language that's there that the JSON schema defines is a vocabulary, and the vocabulary it provides has lots of different keywords. So there's the type keyword here, required, properties, and so on. These are all keywords which direct, or describe something about our data. So type is a keyword that we'll see several times through the schema here. And it describes, the type that we're expecting, whether we're expecting an object, or in this case over here a string, or over here an integer. So there are, the common kind of types you would see in any kind of data. So we're saying that we want, because this is at the top level of our schema, we're saying that the data we're validating, we're expecting it to be an object. And for object types, you can specify the required properties. And you can see we've got this properties object here. So you'd give it an array of the properties that are required, which is a really nice way of being able to kind of see up front, oh, here's the data, what we talked about earlier about there being this kind of self-documenting aspect. You can really kind of quickly glance at the schema and see what the required things are to send through. But as we'll see in a moment, it actually has a functional application of ensuring that the required properties exist. So one of the things with JSON schema is that depending on the type, you might have type-specific keywords. And required is a type-specific keyword that you use alongside a type of object, and the same for properties. And as we kind of jump down into the properties that we're expecting in this object, you'll see then we specify the properties, what their names are. And then here we've got schemas. So you'll see it's kind of schemas all the way down. So, we've got this top level schema here with the object. And then inside here for this name property, we're saying, here's this schema, which is, we expect that name property to be a type of string. And then we've got a type specific keyword, which applies for string type, where we specify like a minimum length and a maximum length. And we're doing similar down here then for the ingredients. And then again, over here for the time, we've got the type, which is an integer, and it's got a type specific keyword for integers, which allows us to specify the minimum that number should be. So that's kind of a sort of a quick run through of what the schema is doing, or what it's describing, what it's expecting. I'm just going to open up Insomnia to make a couple of requests to our API.
Just very briefly, because you were talking about the types and the type-specific keywords. So roughly, how many types are there? So if I'm thinking about learning the language, like how many of these types would I need to learn if I wanted to know all the ones that there are in there?
So the nice thing about JSON schema is that JSON schema uses JSON schema to describe itself. So if we take that
that's
URL,
the fun with each schema language, right? There's always a schema for schemas.
Yeah, the meta schema. So here we can take that URI that we had there for schema, and we'll use curl to request it, and that allows us to actually see what we've got in terms of types. So simple types, we have array, boolean, integer, null, number, object, string. And then you have slightly more complex types, such as arrays and objects. But yeah, the basics kind of here is, you've got around what,
Okay.
1, 2, 3, 4, 5, seven or so.
So it's a manageable set.
It's manageable, yeah, and it maps pretty closely to the primitives you have in most languages as well. So you're not really going to have to learn completely new concepts, hopefully, here.
Okay, good. I interrupted your way towards like showing us what the schema is actually doing, or the schema in action.
Yeah, absolutely. So we've got this API up and running. It's using our recipe schema, and we'll just take a quick look back at that in a moment. So we're expecting a name and ingredients, and those are our required properties. So any payload coming into our API must contain those. So if we take a look at what we have, we've got a name, nice tabbouleh salad, and then we're going to pass through the ingredients, which is just a string of comma-separated ingredients. Now, if we make that request through to the API, we'll see the response come back that everything was fine. We've got a 201 created. Presumably in the real world, that'll put a recipe into a database for us. Now, if we head over to this request here, which is actually invalid, so it's missing the name. And if we put that request through with just the ingredients, we'll see that we get this error back. And it's telling us precisely what's wrong, that the body should have a required property name. Now, what's happened kind of under the hood here is there's a bunch of, this is development kind of debug output. But what we can see is here's the kind of array of errors that AJV, another JSON schema validator, as it's taken our data, validated it against the JSON schema for our recipes. These are the errors that it's found. So it gives us very specific data. And then the Fastify framework has gone and formatted that into a nice message for us that we see here. So we can kind of, we've got something really kind of human readable, so we can go ahead and fix our requests.
So what you're showing us here is like a completely generic error message. It's nothing that you've created for the demo. It's just whenever you use that setup that you started with, this is just the generic message that you'll get.
Yeah, absolutely. So it's created by the validator, its implementation. So it'll vary by validator library depending on how they decided to handle the error messages. But like you say, it's completely generic, and I don't expect most of validators to be doing this.
But it's I would say if I used an API and it would send back this response, I would already say, okay, that's helpful. It tells me something. Maybe it could be more specific or more helpful, but it's a pretty good starting point, I would say. And it was pretty much zero effort, right? So that's really nice, I think.
Yeah, it's a great foundation, and there we probably won't get to cover it today, but there are definitely opportunities with JSON Schema where you can set custom error messages for fields. So you could, for example, then link to documentation, the developer documentation that gives more details about the error. But yeah, it's a great kind of starting point as like a base level for giving some kind of developer feedback. And we can take a quick look here at another one. So if you recall, we specified that our ingredients must have minimum length of 1. Over here, minimum length of 1. And now if we make a request with this empty string for the ingredients, it gives us, again, a generic but really specific error message saying, here, the ingredients shouldn't be shorter than 1 character. So you immediately know what's going on, and we haven't let that junk data go into our application either. So.
Now I'm of course wondering what kind of recipe would actually make sense that has a 1-character ingredient list, but I think that's a different question. Let's assume there is something like that. It could be some emoji, right? Something you put.
Absolutely, it could be.
Okay, now this one is pretty minimal as an example, and
yeah,
I think your story, right? So I like your story that you put together. So your story is that, well, ingredients, you can have that as a string, but then you have to parse it maybe and turn it into different ingredients, and that can get messy. So you could do better in terms of building a JSON model for it, and then that is like the next step that we'll take, which is a little bit more advanced, but still relatively, I would say, basic, where we improve the schema, so to speak, to to handle something that is a little bit more expressive as a JSON payload.
Yeah, for sure. So as you were mentioning, we've kind of got this comma separated string right now for our ingredients, which isn't a particularly structured way of storing our data. It would be nicer if our API actually accepted this as an array of strings. So we've got the current kind of subschema that we have here for ingredients specifies it should be type string, minimum length, and a maximum length. We want to reuse that, but I'm just going to cut that for the moment, save it to the clipboard. And what we're going to do now is change the type of ingredients to be an array. And then we use the array type specific keyword, which is min items. So we can say that the ingredients array that we receive comes through must have at least one element in it. Similarly to how we didn't want an empty string, we don't want an empty array. And now we can say for any items in that array, we want to apply the schema that we had before. So this subschema for the string. So any item in this array of ingredients should be a string with this minimum and maximum length, and we should have at least one item in the array. So we're able to reuse what we had previously, but make things a little bit more structured.
And now we have like a little bit more sophisticated JSON model to work with, and it definitely looked like adjusting the schema wasn't too much work. So that's good. And you already have like an updated recipe.
So we can try and actually put through the old format now that we've saved that. The dev server is automatically restarted. So if I put it through the old format with a string, it's going to complain at us and tell us that ingredients should be an array.
Yeah. Well, I mean, we did make a breaking change, right? So shame on us, but we did.
we should have versioned this, absolutely. So now then, if we go and give it an array instead, we'll see that everything was fine, and it validates that against it. We could, for example, to check that rule, we can pass through an empty array, and it should complain and say, okay, you haven't got enough items in the array. And similarly, we can pass through an empty string in that array, and you'll see that, yeah, it's going to complain. It will tell us the exact item, bearing in mind that arrays are usually 0 indexed. So yeah, the second item here is an empty string. So then you know what to go and do. So that's kind of just an idea of how you can start layering things up and sort of nesting schemas in to get kind of stricter and more specific validation.
Now we have the next step. So we talked about this, right? So we started with a very simple example. Now you came up with a little bit more sophisticated version that still looks pretty simple as a schema. I mean, the schema is still very kind of short and readable. Now, the next step, or the last step, then also is the question, okay, and now if you want to go like a little bit crazy, or you just are into more complex ways of the kinds of things that you want to allow and describe, what can you do then? And this is something where I think you came up with a really interesting example. So give us a little intro here, please.
For sure. So in JSON Schema, I think I mentioned briefly earlier, you can have references. So you can say where a schema can reference another schema. So this is Understanding JSON Schema, which is available through the JSON Schema website. It's a free online book. You can also get it in PDF format. And so we'd use this ref keyword. That's how you reference another schema. So it gives the example here of, let's look at this one here. I think it's a bit of a better example, and I'll bump up the text size a bit. So you can see here that we're saying first name and last name, and it's got this ref keyword, and then it's referencing it. So hash means the current schema, and then this is a JSON pointer, this with all the slashes and everything. So it's saying here, then it's referencing this defs and then the name. So it means that both these fields can reuse this schema, which is defined here. Now, obviously, this is quite a trivial example where it's just validating a string, but you might have something more complex, such as an address, like a shipping and billing address. And then you might have that stored in a separate schema, so in an address schema. So refs are a way in JSON schema of being able to reference either within your own schema, you might have another schema defined like we do here, or you might have a completely separate schema elsewhere that you want to reference. And it kind of creates that sort of reusability and allowing you to avoid duplicating all these kind of validation rules.
And I would assume, right, in like a little bit more, let's say, complex scenarios, this kind of like building up a type library, so to speak, that you can then pull into schemas and reuse, that probably is a relatively common thing to do, right?
Yeah, absolutely. So I think in a larger API, you would want to kind of, have this kind of almost kind of like a cookbook of different schemas that you can draw on to start building other schemas. I've definitely worked with applications where that's happening, because you don't want one part of your application to be defining an address in this way and another part to be defining it differently. You really want to try and reduce this down to single sources of truth as much as you can. So refs are really kind of powerful thing. And I was poking around earlier to see what kind of fun things we could do with refs. And I found out that we can actually create recursive JSON schemas. So those are schemas that are referring to themselves. And what we can do then in terms of the schema that we have here, so we've got our ingredients, and let's just take a look at the actual data that represents. So here's, we've got this array of ingredients. We've got this tabbouleh salad that we're making. And say, for example, we want to add something else to it. We might want to add a secret sauce recipe. So you come across the classic thing in a recipe book, you're reading through and it's got the ingredients, and actually it references another recipe that you need to make that's one of the ingredients for the recipe you're making. And so I thought it'd be kind of nice if we could then use this kind of whole referencing, this recursive referencing to actually be able to embed another recipe in our ingredients. Now, if we try and do that now and pass this through, we're going to get an error because it's complaining that this part here should be a string. So now we can go and try out ref and see how we can use that to allow this kind of recursive reference. So if we take, again, this item schema that we have here for the ingredients array, and we'll just cut that for the moment. And now we're going to use the one-of keyword. Now, the one-of keyword accepts an array, and it's basically saying that the ingredients field, or the ingredients property rather, must be satisfied or must validate against one of the schemas contained in this array. So we've got the simple case, which you saw, which is a string, so it's a single ingredient string. Or we can now use the ref keyword and say it must either be a string or it should be itself. If you recall from earlier, hash in a ref field refers to the schema that we're in. So this says that the ingredient should be either this schema here, which is a string, or it should be a recipe, which is this schema here.
Okay, now let's check the secret sauce.
Yeah, absolutely. So we've got our secret sauce, the extra recipe that you must do to make this recipe happen, and then we'll pass that through, and now that's all validating.
Great.
And so that's pretty nice. And then I thought, why not take this a step further? How about we nest it even further? So you're making the secret sauce, and then you discover that actually you need to make some tahini. In the previous recipe, it was store-bought tahini in a jar, but now you've got to make it from scratch. And so we're here like 2 levels down in our ingredients, and we're going to pass through another recipe, which is for the tahini. So we'll pass that through. And that's all validating nicely, and we can prove that this is working and validating correctly by going and then changing here and making that an empty string, for example. See what we get back, and it's complaining. So this is where sometimes you get some slightly complex errors with one-of, and where you might want to use a custom error message. So because of the way that it's parsing this, it's trying to apply our data through. If you recall, we've got two different schemas here. So we've got this schema and that schema. And so it ends up going through taking the values and trying them against each of the schemas. And so you can sometimes end up with quite a confusing error message like this. So in this case, you might want to use some functionality in the validator library to actually provide a custom error message, so you don't get something super confusing like this. So something to kind of be aware of.
Yeah, but I think, I mean, I think that's always the trade-off with with generic error messages, right? That some of them are useful, others maybe not so much, but they're all for free, so that's not too bad.
Yeah, absolutely. It's one of those things where you've got a good base level, and ultimately it worked. Just the error message wasn't super useful. It did the validation as we needed it to, and so you can then kind of iterate on that and add in more advanced error messages and error handling.
That's a nice example. It reminds me of I have an Indian cookbook that works like this. You look at a recipe and you say, oh, that doesn't look too complicated, I'll make that. And then you read through it and it's like, oh yeah, this is referencing another recipe. This will take another 2 hours. So there's a lot like that in there. So it's a real world example. I like that.
It's a trap. It's the recipe trap.
And it can go any number of recipes down. That's also because it's recursive right now. There would be no easy way to say it can only have 1 or 2 or 3 nested ones. Right now, it can have any number.
Not that I'm aware of. No, I think this is now going to be recipes all the way down.
But that would be the kind of thing that I guess, right, realistically speaking, where you might say, okay, if you want to limit it to, let's say, just 2 or 3 levels, you might still just keep that schema and then have maybe some other code after that would just check like not too many nested levels and then, raise an error if that happens, right? So I think that's another kind of nice pattern to say, okay, there's this error checking and then there can be another error checking and then you can just pick and choose which works best.
Yeah, I think you're completely right. You've got that opportunity to kind of mix and match, and the whole point, I think, with JSON Schema is it doesn't do everything. It's not trying to be the Swiss Army knife that does absolutely everything. It's just giving you this vocabulary to be able to do some pretty rich things, as we can see here, like with this recursive validation and kind of referencing schemas, but it's not trying to solve every validation problem. So you're inevitably going to want to actually add, probably once you get into more advanced use cases, some of your own application logic to handle that.
It's probably good that it doesn't try to solve all validation problems, because otherwise it probably would not be usable or it would be very, very hard to learn and use.
Yeah, I think so.
So thank you so much for walking us through this. I think you also had like some resources that you wanted to share with us, where I think you made all of this available for people to look at, right?
Yeah, that's right. So everything that's here that we've run through today is on github.com/simonplen/talks. So it's on this Git repo, and all the schema examples are in here. You can spin up the server and play around with it if you really like to. There's even the Insomnia collection, so you can actually go and make all the example requests. So that's all there on GitHub. As we've kind of said, like JSON Schema works with pretty much any language. My specialty is Node.js, so if you're interested in trying JSON Schema in Node.js, head over to my blog at simonplen.com. I've got this article here around getting started with validation in Node.js. You'll also find a few other articles on my blog around JSON Schema. And if you want to reach out and drop me a message, I'm on Twitter at Simon Plend. I'd be really happy to chat about things. And hopefully that all helps.
Thank you so much, Simon. I will, of course, link all these things from the video and put them in the video description so that everybody can find them very easily. I think this is a great way to get started with JSON Schema, to understand what it can do for you. And I think it was a very good way to show us that you can start really easily. It doesn't take a lot, and you get like pretty nice things out of the box already without writing a whole lot of code. And I think that hopefully will encourage some people to go and check out JSON Schema.
Absolutely. Thanks so much, Eric. Thank you for having me.
Yeah, thanks for taking the time, and thanks everybody for watching. If you liked it, please give it a thumbs up. Check out Simon's resources and his blog. And with that, we're done for today. Thanks everybody. Until next time, have a great day. Bye-bye.